Another application of the PERT formula is when populations get so big that the best way to model them is to use a continuous growth model. So here we'll use a continuous growth model. This question is here. Now, of course, they would give you this formula or something similar when you're doing the question. They might change the letters around. Sometimes the same formula looks like that. You'll often see A with a 0 meaning the amount that you started with. But it means the same thing. Whatever they give you in the question, use the one that they've given you, because otherwise you might be changing letters around, and then you're going to lose half marks for those kind of things. So we've got 1.38 million. We want to figure out the projected population in 2011. So we know we started with 1.38 million. The rate is 1.7%, so change that to a decimal. In 2011, how many years later would that be? 30 years later. And this one, there's nothing we need to do other than type it in. As a shortcut, I'm typing in 1.38 instead of all of those numbers. What am I doing? And to the nearest tenth, should get 2.3 million. In part B now, when will the population reach 6 million? And this is where, this is a huge application of this because they look at population trends for cities, they look at population trends for countries, they start to think, what do we need to do if things don't change? This is what our infrastructure will need, and this is the kind of city planning or country planning that we need to do ahead of time so that we don't get into a disaster either economically or environmentally or things like that. So 6 million, I'm going to put everything in millions here. So instead of writing all those zeros, I'm going to go 6, and instead of writing 1,380,000, I'll go 1.38. The rate, if it doesn't change, stays the same, and we're solving for time. So if I divide both sides by the 1.38, and now we can take the natural log of both sides. And of course, we know the natural log of e is equal to 1. So dividing both sides by 0.017 should give us the time. $86.5 years. Now let's look back at the question. What did it ask us? Did it ask us when? So in 1981, it was 1.38. Does this mean in the year 86? It means 86 and a half years after 1981. So if we do that, 1981 plus 86.5 years, that is now it's 2067.5. But if I write in the year 2067 or between 2067 and 2068. That's probably even a nicer way of writing it. So between the years 2067 and 2068, the population will reach 6 million. Yes? That would be fine. As long as you've got the 86.5 here, you could show your math that becomes 2067.5, and then your written statement shows that you have an understanding of what's happening. So because it's a word problem, it's good to have that written statement there.